This video will demonstrate how to use PickX with Flatiron's project data, both training a new neural network model on Flatiron's data, using the new model to pick existing Flatiron's projects, and finally, we're going to use that new model to pick a raw SegWi file. Training a new PickX model with Flatiron's data is a very simple process. You'll more than likely create dozens of models on different basins. All right, to prep the Flatirons projects for PickX, it's pretty simple. Each Flatirons project needs a good set of first break picks. They don't have to be perfect, but the closer the better. And finally, each Flatirons project needs a move out trend defined. So for example, let's go to this Flatirons project and go to the move out trend window. Now there's a trick to defining a move out trend for use in PickX training. And the trick is, it's counterintuitive. You don't want your move out trend to be too accurate. You want a little bit of wobble to it around the first arrivals. That will help PickX create a more robust model. So I'm going to a couple different locations and applying a move out trend. And that's probably going to be good enough. All right, let's close Flatirons and go to the main PickX window, and you select Train Segmentation Model, use Flatirons project data. You can use Phoenix project data if you have any. I think most new PickX users are going to have a bunch of Flatirons projects with good picks. All right, let's go here. All right, the projects I'm showing on my screen now are all synthetic projects with varying levels of noise. What we're going to do is we're going to use a moderate noise and a very low noise uh, synthetic data set to train the model. And then we're going to see how it performs, the new PickX model performs on a high noise project. All right, so let's select these two projects and go to next. And we're going to call this demo 1. I would not stress too much, be concerned too much with the options you choose on your first training run. It's very simple to do this, and you're, like I said, you're more than likely to create dozens of models. Okay, the standard UNet approach is pretty close to the best. Mean square error, I would not change that. Okay, we're going to choose a time window of minus 400 to plus 400 milliseconds around time 0. We're going to apply the move out trend, flatten the gathers of the move out trend, and then select that time window. No pick shift is needed, and the transition window of 16 milliseconds is fine. The noise measurement cutoff we have to be concerned about in this case. We want to use every pick, no matter how noisy the trace. So we're going to change that to 0.99. When you're training real data, you may want to have that noise cutoff fairly low, like 0.2, 0.4, something like that. And that will ignore traces or picks on very, very noisy traces. Okay, training EPIX5 is fine. The learning rate you don't have to fiddle with. These options are actually pretty robust, and I rarely change them on most surveys. Finally, you can actually add noise contamination to the data that you're reading in. These data already have a lot of noise applied to them, so you don't really have to add very much at all. These first 6 parameters, you can add these patches of sinusoidal data at random to your input data. That can kind of mimic field noise on your survey. The white noise, go ahead and change that to a very low value, 0.1, because as I said, these projects already have noise applied. Next, I never use this option, apply bandpass filter, and you click finish. If you have PickX open, if you have Phoenix open, you can go to Phoenix and watch the progress of your training run. Okay, the training job is finished. It took about an hour on my very old laptop with a very old GPU. Let's go ahead and use the new model to pick a different Flatirons project. The only thing we have to do is make sure the Flatirons project has a move out trend defined. So let's go ahead and open the project we're going to pick. We're going to pick the high noise synthetic data set. And let's go to the move out trend display. And you can see this data is so noisy, it's almost hard to see the first arrivals. But they're right about there, it looks like. Let me try that again, fumble fingers. Okay, that's all we have to do to Flatirons. Go back to the PickX window and select the Flatirons project picker display. It's quite simple. Let's open the Flatirons project. Make sure you got Canon Home set properly and your project should show up here. I've only got one version, the default version, and the units are meters. It doesn't really matter for this project though. Click on OK. And here we are. By default, from a prior project, I had a move out trend applied and the PickX segmentation picker being applied. Select the PickX option and make sure the parameters are set correctly. It's actually very important to make sure you choose the correct pick name. This is going to get overridden in your Flatirons project. So let's put it in back 2, for example. You can see the data is extremely noisy, but it looks like the PickX picker is doing the right thing in most locations. You can see it's seeing through this off-plane noise quite easily. Okay, that's really all you have to do to prepare the PickX job. When it's ready, just click on Start Batch Process, Single Thread, Single CPU, and away you go. As an aside, this is going to be modified soon, so you can run this on a cluster, assuming each node in the cluster has a GPU. Okay, so it's running, and you can open up the Phoenix display and monitor the progress. It's going to take this about 10 minutes to finish. The batch pick job is finished. Let's take a look at the results in the Flatirons project. Let's open a picker window. And by default, I think the first break picks are on. Let's turn those off and look at back 2. These are the ones we just picked in PickX. And you can see they look pretty good. Let's apply the move out trend. And they look very good. So the way to actually QC these picks, I'm not going to do it in this video, is you start running solutions, run a delay time solution, tomography solutions, and look at the errors and look how the solution looks. But offhand, I would say these are very good. Next, let's pick a seg.y file without first importing it into either Phoenix or Flatirons. Go ahead and click the seg.y picker window. And before anything else, we have to define a header map. So click on the seg.y dictionary editor button. And let's select our seg.y file. We're going to use the synthetic low noise just for grins. And next, let's select the header map for that. I've already defined this header map, so I'm not going to go into it too much detail, but you do have to define the shot and station line and point number and the shot and station coordinates. Okay, that's already defined. And once you have that, you just select the seg.y file, synthetics. Let's pick the moderate noise seg.y file and then select the correct header map and click on import file. When you click on import file, it's going to scan the seg.y file and extract all the geometry information. This can take roughly about 10 or 15 seconds per million traces. So if you've got 100 million traces, click import and then come back in about 15 minutes and you should be ready to go. This survey is about 3.3 million, so it should take less than a minute to do this scan. Okay, so the It's a shot plane, which is correct. Trace count looks correct. And the shot and station counts all look correct. A dialog is telling you you should define the move out trend curves before you apply the neural net picker. So click on OK, and then go to the move out trend definition tab and click over here on the base map to select a shot. And it's just like defining a move out trend in Phoenix. That looks good. Okay, now go back to the seismic display and let's group things by station line number, and let's apply the move out trend. Okay, that looks reasonably good. Data's not too dirty. All right, now let's add the neural net picker. Okay, so we've only got one model defined in this Phoenix data directory, so it's selected by default. Give it a name. Let's go ahead and call it pick_NN. Once we do that, we have to go down here to the bottom and say we're going to export pick_NN and say where in the header are we going to store it. So let's put it at byte offset 225. And that's all you have to do. You can click around the base map to see how the picker looks in different areas, but this looks pretty good. I don't see any problems with this picker at all. So once everything looks correct, go ahead and click on Start Batch Picker and wait until it's done. Roughly, depending on your machine, it'll take about a minute per million traces.